All right, guys, welcome back. So we are on chapter two for the geosphere, going with our Earth materials for this unit. Last chapter was on the hydrosphere. Hydro meant water. We have the next one with geosphere. So we know our big question right down here is, what is the geosphere? I'm so glad you asked. I'm really excited. Okay, really glad you asked right there. Okay, I'm going to read a little bit on this lesson part. I'm going to bounce around a bit. I've made a few notes on here, just a couple stars, little arrows, cute little puppy dog with some stars thing for my big question. Very nice. Okay, so although Earth's surface is mostly covered with water, the planet itself is made almost entirely of solid rocky material. There are different layers of this material, and each layer has different properties. Taken all together, all the rocky material that makes up the Earth is called the geosphere. Oh, well, hold on here. That literally just answered my question right there. Cool. Well, I'm done. That's enough with my lesson. I got a little bit longer. Let's go some more. Okay. So also have my vocabulary right there that the geosphere is the Earth system that contains all of rocky layers. I will accept that as an answer as well. The geosphere includes all of Earth's visible geologic features, such as mountains, as well as the inner rocky layers that you cannot see. It includes all of Earth's rocks and materials. The bits of rock in soil are also part of the geosphere. So if it's a rock, it's geologic. Okay, but not the wrestler though, not the actor. That's different. That's not geologic. Okay, like the hydrosphere, the geosphere is dynamic, which means from the last chapter, constantly changing a lot. Okay, there's a process that goes to it, which we're going to talk about later on it. Okay, sometimes it takes a long time for these to change. Sometimes some of them go a little bit quicker. Okay, so down here on my word parts right here, the word part geo means earth, as in ground or soil. Okay. So, example right here, mountains are just one part of it. So, for us, one of our things that we need to know in fifth grade is the geosphere has layers. Our planet has layers that go with it. Okay. So, I'm just going to kind of scroll down here to the picture because that's my main one I really want to focus on right now. Okay. So, think about it. It's cut into slices. There's all these little layers that I kind of see right here broken down. I'm going to go ahead and just start out right there. So the very outside layer, the one that I'm kind of sitting on right now, that's known as the crust. Okay, that's everything that's on top. Then, quite a few more feet down, you go to what's called the upper mantle. After that upper mantle, congratulations, you are now in the lower mantle. Weird, fun names. They really did their job naming things. Okay. Then after the lower mantle, you get to what's called a core. The core, very similar, I always think about is like a baseball core. The inside, after you slice it up, you got all that layering, rubber string now. Okay. Then you've got this layers also in here. You've got the outer core, and then inside of that is the inner core. Again, they were really intense on those names. Okay. A couple little things up at the top right here. There's all 5 different layers. Okay. I just explained them right here. We've got inner core, outer core, lower mantle, upper mantle, and the crust. Okay. Couple things about these. The inner core is a ball of solid metal that contains mostly iron and is about 3/4 the size of Earth's moon. Wow, that is pretty big. Scientists estimate that the temperature of Earth's inner core is approximately 8,000 to 10,800 degrees Fahrenheit. And if you're also looking at Celsius, at 4,400 to 6,000 Celsius. They made this estimate based on their knowledge of the melting point of iron. The iron in Earth's inner core is under so much pressure, it's unable to melt. Wow, so that hot, because obviously that's pretty hot there. But when they talk about pressure, that means it's just constantly pushing on it so hard. I mean, the whole entire planet literally pushing on this thing. Okay. The outer core is approximately 1,400 miles thick. It is made up of mostly of the metals iron and nickel. The metals in the outer core are not solid like the iron in the inner core. Instead, they behave like a soft plastic and are described as liquid or fluid. So they move a little bit. Moving metal. Okay. The layers just outside of the outer core are lower and upper mantle. Together, these mantle layers make up most of Earth. Most of these rocks are solid, but they are part of the mantle where the rock is fluid, almost like plastic. It's able to move slowly over millions of years. Okay. The uppermost layer of the geosphere is the crust. We live on the crust. I like the crust. That's just not a pizza part. Okay. Over geological time, these plates that are totally encased on Earth's crust are broken into certain sections. Okay. They move, they slide, they grind up. Okay. They do a lot of weird things. New crust forms when liquid rock moves up through the cracks and then cools. So, right down here, when one part of Iceland, you'll see where two plates in Earth's crust are pulling away from each other. If we notice right here, you can see it kind of fits like a puzzle piece. At one point in time, those were kind of pushed up, butt up against each other. And then as time kind of went on, these plates started kind of moving away from each other. And this is a very, very slow process. Okay. So this doesn't happen overnight on here. So this is a very slow process, you can tell. And even still moving because it's got more cracks getting there. So pretty cool. Now, different kinds of rocks. I love rocks, okay? Earth's crust contains three types of rocks, three different kinds. You got igneous rock, metamorphic rock, and sedimentary. Rocks are classified as belonging to one of these groups based on how they are formed in the rock cycle. Igneous rock can form at Earth's surface and below it. Magma trapped below Earth's surface can take thousands or millions of years to cool. That takes a while. Igneous rocks formed underground this way have a rough, coarse texture when compared to those that form at Earth's surface. Down here, I have two different types of rocks right here. I have obsidian. It's a type of glassy rock. That is a sign that it formed from magma and it's cooled very quickly. You can still even see the waves on here, okay, from the liquid part of it. Okay, very cool. Where we look at this one, this grainy one, where you can actually see almost like different pieces kind of formed up on there, or it's just kind of chunked together. Okay, grainy crystals in granite are a sign that it cooled more slowly, not as fast. Okay, up here, a couple things to remember. Hot molten liquid rock called magma can flow up through the cracks. Once it goes through the cracks and gets above the surface, it is identified as lava. The lava cools quickly on the surface and hardens into solid rock that can have a smooth, glassy texture. Bow. Smooth and glassy. Now, sedimentary rock, one that's around Colorado quite a bit. Sedimentary rock can form in a few different ways. Wind and water can wear down exposed rock and Earth's surface into sediments, or rock material that has been broken down into tiny pieces. The word sediments down here, sediments are rock material that has been broken down into tiny pieces. That means tiny, tiny, tiny little pieces are kind of pushed together to make a larger rock. Okay, type of sedimentary, you can kind of chunk off little bits of it. Another kind of sedimentary rock forms when a large number of living things die and become stuck together after they decompose. One kind of this sedimentary rock is coal. That's right, coal. My barbecuers, my guys that like to grill masters. I don't know how many fifth graders I have that do that, but that's cool. Which forms from dead plant material. A third kind of sedimentary rock forms from minerals that have been dissolved by moving, rotting water. Moving, running water. These dissolved minerals eventually separate from the water and become solid again when conditions change in the environment. Metamorphic rock. Oh, yes, metamorphic. Metamorphic rocks forms when intense heat and pressure below Earth's surface cause physical and chemical changes to that rock that has already formed. So one of the key words on that one is chemical. Sometimes these rocks are igneous or sedimentary. Sometimes they are other types of metamorphic rock. This heat and pressure causes changes to the mineral makeup of those rocks. The movement of Earth's crust causes change. We said a little bit when we showed the picture of about the movement of crust plates, both slow and sudden changes, pressure from two plates moving in relation to one another, against each other, side to side, away. Okay, sometimes plates rub against each other on this part, sometimes they pull apart. The photo on page 11 showed that. Okay, plates can also move up and down. So one plate here, one can move up, the other one can move down. Felt like I did a little dance right there. Sometimes one plate will slide actually underneath the other. Long-term plate pressures causes the buckling or sliding of crust that forces up some of these types of mountain ranges. So when they said the slide part, actually kind of push underneath it. All right. Now, part right here, we're going to have a words to know right here. We have this phrase called a seismic wave. On this part, a seismic wave is a transfer of energy through rock and at and below Earth's surface. Earthquakes occur when the disturbance of matter from seismic waves causes the ground to shake. Okay, so that's a large buildup of pressure on that one. The strength of an earthquake depends on the amount of energy that is released. So one in United States we have is in California on San Andreas Fault. This photo shows a major fault line right here. You can actually see the line right there. Okay, a lot of earthquakes in that area. All right, moving down. Okay. While most changes to the geosphere happen over very long periods of time, some changes also happen very, 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 very quickly. An example of rapid change is to the geosphere is a volcanic eruption. We talked earlier about when magma is underground, lava is on top of the ground. I'm going to read this part right here. Volcanoes are openings in the crust through which magma emerges as lava. Volcanic eruptions occur commonly along plate boundaries. Wonder why? I mean, there's cracks in the ground, pressure underneath, duh. After many eruptions, lava piles up and can form entire mountain ranges. When volcanic eruptions happen along cracks in the ocean floor, the buildup of crust form underwater mountains. Their peaks can rise to emerge above the water surface and creates islands, such as the Hawaiian Islands. Aha. Maui, I knew you didn't pull up the islands. Haha. Some volcanic eruptions can be sudden, explosive, causing lava and ash to shoot into the air. Other eruptions can be slow, more continuous, with ribbons of lava slowly flowing from the opening. Okay, so last little bit is the rock cycle right here. Boom, 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 boom. The rock cycle. Okay, the rock cycle is a process through which rock changes form through igneous, sedimentary, and metamorphic because, like we said, it's a dynamic system. It changes over time. Over time, the tiny pieces get pressured, less heat, more heat, magma melts them, everything, okay? So magma cools either at or below Earth's surface, forming new igneous rock. The process of the rock cycle can happen in any order. There is no beginning and end. So if we look down, oh, the rock, how dare you get here? A little bit of a pun. I did not do this. It's the rock cycle. I love memes. All right, that's enough of that. But here's this. Okay, now we have right here, going from, I'm giving a little drawing right here. The first couple ones, we have sedimentary, we have igneous, and we have metamorphic. So in the middle kind of shows down what happens, how one can turn into the other. So let's go ahead and start at igneous rock. An igneous rock can turn into sedimentary by breaking it down into smaller pieces, okay? So if it breaks down into smaller pieces, turns into sedimentary rock. unless the sedimentary rock decides to melt, to, I don't know, to melt really, really hot, lots of pressure on that one, maybe not a whole lot, but sedimentary rock melting down goes back to igneous. Okay, so let's go ahead to sedimentary rock. Sedimentary rock can then, through a lots of heat and pressure, can turn into a metamorphic rock. That's right. They can go to that deciding, okay, changing. Remember, physical and chemical changes on that part. Or metamorphic can decide to break down again and turn into sedimentary. Okay. Notice for sedimentary, they're both requiring breaking down because it's tiny little pieces. All right. So metamorphic rock, it can melt to make igneous rock. Oh, the melting in the little waves part. Okay, got that with igneous rock again. Or igneous rock can decide to, get a lot more heat and pressure onto it, become metamorphic. It can be anything on here. So notice a couple of things to make it other. The sedimentary rocks both have to be broken down. We have melting happens to be igneous rock. And in order for metamorphic, needs some heat along with a lot of pressure from the ground. Okay, that is all that I have for you guys. Okay, that is it. Have a fantastic day. Rock on. I forgot to hit the stop button. Don't judge me.